Hello disciples, welcome back to Stats Cosmos. I want to tell few things before we get started. Number 1, with the right amount of hard work, patience and practice, we can get through our goal for sure. And second one, I am not promoting anything but my passion of learning. So feel free to follow me, and if you think there is something I can do better, leave a constructive comment below the video. I'll try to incorporate that into future videos. Now let's go ahead and let's dive right in. In this video, we are going to look at uniform distribution. Let's get started. Here, for understanding uniform distribution, consider the events or processes of a coin flip and the roll of a die. What are these have in common? Think about it for a second. Well, they both have a fixed number of outcomes. So, the coin flip has 2 outcomes, heads or tails. The die roll has 6 outcomes. The number is 1, 2, 3, 4, 5 or 6. So, they both have a fixed number of outcomes. Also, assuming they are both fair, the probability of each outcome is the same. So, for a coin flip, the probability of head is half and the probability of tail is half. So the same probability for each outcome. Now, how about the die? The probability of any number being rolled is 1 by 6. There are 6 numbers on the die. They all have the same probability of coming up. Therefore, the probability of each outcome on the die roll is 1 by 6. So, just think about these two things as we proceed. Let's look at our coin flip. What has 2 outcomes, heads or tails? The probability of each outcome is the same and its probability is half. And if we graph that, we can see that for heads we have a probability of half. If you see on the y-axis, they are on the left, it goes up to 0.5, and for tails it's also the same. Now note that half plus half is 1. We already know that probabilities have to add up to 1. This is uniform discrete probability distribution. What makes it uniform? That's because the probability of each outcome is the same. The top is flat, it's straight across, and in this case, it's discrete because a coin flip can either have 2 outcomes, heads or tails. Now, how about rolling the die? It has 6 outcomes. They can be 1, 2, 3, 4, 5 or 6. The probability for each outcome is the same. So for 1, it's 1 by 6. For 2, it's 1 by 6. For 3, it's 1 by 6, etc. And you can see the 1 by 6 plus 1 by 6 plus 1 by 6 and on is 6 over 6, which equals to 1. So this is also a uniform discrete probability distribution. It is uniform because the probability of each outcome is the same. You can see there is about 0.167. So it's flat across the top and it's the same for each outcome. Now, let's talk about a real world situation. Let's say that the college bus is supposed to arrive at the student union stop at 8:30 a.m. However, those of us who ride college buses a lot, records indicate that the bus arrives between 8:25 and 8:35 in a manner that seems random. So, the bus seems to arrive between 8:25 to 8:35. Somewhat randomly, there is no time around which it seems to gravitate. So, we can think of that is the bus arrival time during any 1 minute interval is just as likely as the next 1 minute interval. So, from like 8:25 to 8:25:59, the probability of bus arriving during third minute is the same as the next minute, which is the same as the next minute, and so forth. Across the 10-minute span, so we have taken our 10-minute interval and sort of chopped it up into 1 minute time span, and the probability of bus arriving in any one of those time spans is the same. So here again we have a uniform distribution. You can see that is the height is 0.1, which of course is 1 by 10, and it's straight across. So again each outcome is 1 by 10, and if we were to add up all these probabilities, it would be 1. So this is a real life example of discrete uniform distribution. I hope you all enjoyed this video and you understood it well. Thank you so much all for watching this video. We'll continue with the next video.